Good morning, students. In the previous class, we already discussed about some real life problems based on parabolas. In the type number 4 equation, for example, x squared equal to minus 4ay, we already used it. In the same model, today we are going to discuss few problems. Read the question once again carefully. A bridge has a parabolic arch that is 10 meter high in the center. Look out some rough diagram. We are going to draw a rough diagram now. See, it is a bridge. Consider it is a bridge. Over this we are able to see some parabolic arch. You are able to common life, you are able to see this type of bridges in many places. This is a parabolic arch. Many parabolic arches are there. We are selecting only one parabolic arch. We are going to discuss. See, a bridge has a parabolic arch, so that we are taking only one arch. That is 10 meter high in the center. See this center, it has 10 meter high. Then at the bottom, this is the bottom, consider the bottom, 30 meter wide. It is 30 meter wide. So from this we have 30 meter wide. At the bottom, find the height of the arch. 6 meter from the center. See, this is the center. We are thinking from this place we are moving 6 meter away from the center. Now we are going to see height of this bridge. Consider this is the height of the bridge. We are going to find out. Once again listen the question carefully. 10 meter high, then 30 meter wide. From the center we are moving 6 meter away from the center. After that we are going to look out the arch. Then we are going to calculate this height. This is the required height. We need to find this required height. This is the rough diagram as per the given statement. So we are able to see a bridge. In this bridge we have a parabolic arch. See, this is a parabolic arch. 10 meter high at the center. This is 10 meter high at the center and 30 meter wide. 30 meter wide at the bottom. Find the height of the arch. 6 meter from the center. See, there is a parabolic arch here. I am standing in the middle. In this middle place, the height of the bridge is 10 meter. I am going to move 6 meter from the center. Now I want to calculate the height of the bridge. You can think whether this height, required height, decreasing from the 10 meter already given or increasing. Calculate, think about yourself. Center itself, it has 10. You are moving 6 meter away from the center. See, 6 meter away from the center. Now we are going to calculate the height. This height must be lesser than the given. We have to calculate. Now listen, we are going to draw a fair diagram. This is the rough diagram as per the data. We are going to draw a fair diagram. Here fair diagram means parabolic diagram as per the given data. Now we are drawing this arch. Consider this arch is in the form of type number 4. Now consider this is the vertex, x-axis, then y-axis. The meeting place must be the vertex. From the center, how much height it is? 10 meter height. Then total bottom is 30 meter. We are splitting with the help of y-axis. Therefore, it should be 15 meter each side, 15 meter. Now, we are considering this is a point. Consider this point. This point must be 15 and the y coordinate 10. 15 is x coordinate positive, comma, here y coordinate must be minus 10 because this point lies in the fourth quadrant. Here consider this is also 15 but negative, here minus 10. Why we are taking negative 15? Because it is lies in the third quadrant. Now this rough diagram as per the given data we have to draw first. After that we are converting them fair diagram with the help of the coordinates, that means quadrants. Now vertex, one point lies in the fourth quadrant, another point lies in the third quadrant. Now what is the equation of this parabola? It looks like the fourth type of the parabola. What's the equation of the fourth type? X squared equal to minus 4ay. Type 4. Type 4 means open downward. It is nothing but open downward. Now we have to find the value of a. How is possible? This parabola passing through 2 points. So we are able to substitute this equation passing through, we can select any one point. So 15 comma minus 10. So we are going to substitute here. See, instead of x, I can substitute 15 squared here. That is equal to minus 4. The value of a is unknown. The value of y is minus 10. Then we can simplify. 15 squared is nothing but 225. Here we can get 40a. Therefore, the value of a must be 225 divided by 40. We can cut using the fifth table. So if we are cutting the fifth table, we can get 8 times. Here means 4 times. Again 25, 45. Therefore, the value of a equal to 45 divided by 8. This is the value of a. First we have to calculate the value of a. Listen carefully. This is the parabolic diagram. Open downward, type number 4. Equation is x squared equal to minus 4ay. This equation passing through 2 points. We are selecting one point, 15 comma minus 10. You can select the second point also. Now I am using 15 comma minus 10. Substitute the data. The first data value x, the second data value y. Substitute 15 squared minus 4a. Instead of y, I can replace minus 10. Simplify this equation. 15 squared is nothing but 225. Here 40a. We need to find the value of a. 225 divided by 40. We are able to cut the given data by fifth table. Therefore 45 divided by 8. That is the value of a. Now I can substitute here. Therefore required equation is x squared equal to minus 4. The value of a just now we derived, that is 45 by 8. Then already we are having 1. This 4 and 8 will be removed. We can get x squared equal to minus 45 divided by 2y. This is the required equation of the parabola. So after that you derive the value of a, again substitute in this place. That means x squared equal to minus 4. The value of a must be 45 by 8. While then 4 and 8 will be removed. We can get 2. Now we have to find height of the bridge from 6 meter from the center. Now listen, the total value is 15. From the center I am moving 6 meter. Now I have to calculate. This is the height. I have to calculate this. So 6 meter from the center. I am moving from the center to 6 meter. Away from either side you can move. I am going to one side. 6 meter. If the value is 6 here, here also we can get 6. From vertex to this value is unknown. Say this is y1. This value is unknown. Say this is y1. Therefore, I can select this point as the x coordinate and y coordinate. Here x coordinate is 6, y coordinate is unknown, say minus y1. Once again listen this concept carefully. After derive the value of a, substitute. This is the step number 1. Then we have to find the height of the bridge. 6 meter from the center. I want to move 6 meter from the center. After that I have to calculate the height of the bridge. Therefore from the center I am moving 6 meter. After that I have to calculate this height of the bridge. So 6 meter moving. Then use the height. So this is h. If this value is 6, then again the parallel value is also 6. From vertex to this value is unknown. Unknown value is y coordinate. Say it is y1. This point is 6 comma minus y1. Now I have to substitute this point in the equation of the parabola. Then we are able to calculate. Now listen. This is the required parabola. This parabola passing through 6 comma y1. Therefore the parabola x squared equal to minus 45y divided by 2 is passing through, see, passing through the point P of 6 comma minus y1. So this is the parabola. This point, this parabola passing through this point 6 comma minus y1. If any equation passing through a particular point, we are able to substitute here. See, this instead of this x, I am replacing 6. That means 6 squared minus 45 by 2. The value of y must be minus y1. Now we are going to simplify this one. 6 squared becomes 36. Here both negative will be removed. So we can get 45 y1 divided by 2. We need to find the value of y1. This is the unknown quantity y1. So I have to find the y1. Therefore here y1 means just to cross multiply 36 into 2 divided by 45. This 36 and 45 will be cancelled with the help of ninth table. So ninth table means 4 9. Here 5 9. Therefore y1 equal to 4 2s are 8 divided by 5. 4 2s are 8 divided by 5. This is the value of y1. See, this is the value of y1. I want to find a height of the bridge. See, once again, this parabola x squared equal to minus 45y divided by 2 passing through the point P of 6 comma minus y1. A particular equation passing through a point, we can replace x comma y here. X is replaced by 6 squared minus 45 divided by 2. Y is replaced by minus y. Just simplifying, 6 squared is 36. 45 by 2. Both the negative will be removed. Therefore 45 by 2 y1. We need to find y1 just cross multiplying 36 2 divided by 45. We can cut the values by with the help of ninth table. 4 9s 36, 5 9s 4 into 2 8 divided by 5. Now listen, it is the important place. Many students doing the mistake here only, because you are finding out the y1 equal to 8 by 5. You are thinking this is the answer. It is not the correct answer. See the diagram. We need to find this height. How we are able to find this height? This is the total value 10 units. See, this is the total value 10 units. Already we worked out. Now we need h. How is it possible? Total height 10 minus the value of y1. This is the value of h. See, we need this one. We need this one. How it is possible? The entire value is 10. Just now you worked out the value y1. Then subtraction means we can get h. Therefore, height of the bridge. This is the important place. Many students doing the mistake. They are thinking this is the answer. It's not the final answer. We need h. So that I am writing h. h is the height of the bridge. Required place. So that already we worked out. Given data is 10 minus the value of y1. The value of y1 is 8 by 5. Now take LCM. 50 minus 8. Therefore, 42 by 5. This is the height of the bridge. 42 by 5 meters. Or you can simplify. 42 by 5. 42 divided by 5. You can simplify. So 8 5s are 40. 2. So that means 20. 20 means 4 5s. So we can get 8.4 meter. You can write like this also. Initially I am explaining. From the center 10. I am moving from the center to 6 meter away from the center. Therefore this arch must be reducing. The height of the arch must be reducing. So initially I am explaining this is the 10. From the center it is 10. Therefore we need this h. h must be lesser than the given. So already the given height is 10. You are moving from the center 6 meter away from the center. Therefore we can get 8.4 meter. This is the height of the required bridge. Therefore this type of questions, dear students, read the questions carefully and draw a rough diagram first. As per the given data, draw a rough diagram. After that, you have to convert that rough diagram into a fair diagram. Here fair diagram means in the type of the parabolas. We are having 4 types. Here we are taking the 4th type. The name of the 4th type is open downward. The equation is x squared equal to minus 4ay. After that, selecting the equation, first you have to find the value of a. How we are able to find the value of a? Substituting the point. The equation of the parabola passing through a point. Here the point is, one point lies in the 4th quadrant, another one lies in the third quadrant. The point must be equidistant from the center because it is a symmetrical. So after finding out the value of A, you are getting the equation like this. See here, required equation, substituting the value of A, we can get x squared equal to minus 45 by 2. This equation again, see, this equation again passes through the point. See, here also a point, this is a point, this is a point, you are having 3 points. First we have to substitute the known quantities. See here, both x and y are known values. So you have to use the first known values. After that, you have to find unknown values. This is the procedure to find the values of or height of the bridge. In the same order, we are going to work out the one more problem. Friends, the same type, one more problem. But now the parabolic model may be different. Already we discussed 4 sums based on type number 4. See, a parabolic communication antenna. You are able to see many dish antennas in your home. So, the parabolic communication antenna has a focus at a 2 meter. Now listen, it is a rough diagram here. Consider to be an antenna. Your stand is like this. A dish antenna maybe look like this model. This antenna has a focus at a 2 meter distance from the vertex. This must be the vertex. Consider this must be the vertex. From here, the focus is placed at a distance 2 meter. So this is 2 meter. Already we discussed a theoretical concept. The distance from the vertex to the focus. So that means already we are giving the name V here. Then F is the focus. Distance from vertex to the focus is here A equal to 2 meter. Then what is the question here? Find the width of the antenna. So we have to find, this is the width of the antenna, 3 meter from the vertex. From once again, from here to, we have 3 meters. From vertex to here, 3 meters. Now we are going to find the width. This is the width. We have to find the width. So focus is placed at 2 meter. Now again we are going to work out the width. From the vertex it has 3 meter. Now I am drawing a parabolic diagram here. See, this is, I am considering this parabola as type number 1. Type number 1 parabola I am selecting. This is the vertex V0, 0. From this, focus is placed at a 2 meter distance. In general, focus is A, 0. I am selecting 2, 0 here. In general, focus is A, 0. Here 2, 0. Then we are going to select 3 meter depth here. This is depth 3 meter. So that I am selecting this point 3, 0. I need to find this value. This value is unknown, say y1, because it is parallel to y-axis. That value is unknown. So select y1. So this point may be considered to be a point P. See this distance, x-axis value is 3 here, y-axis value is unknown. So I can say this is 3, y1. So I can say this point is 3, y1. Once again listen, this looks like a dish antenna. This dish antenna has the focus 2 meter from the vertex. So this is 2 meter from the vertex. So I can select focus as 2, 0. Now I have to find the width. This is the width, entire is the width. Width of the antenna 3 meter from the vertex. That means this is the depth. This depth is 3 meter. In this depth I am going to find out the width. So I have to find y1. So if you are multiplying twice, we can get the width of this antenna. This is the just information. Take the rough diagram first. After that convert into a fair diagram. That means with the help of the parabolic diagram. Now we are going to select the equation. Now listen. Equation of this parabola is, see here I am selecting type number 1. Therefore equation of the parabola is, equation of the parabola is, selecting the type number 1, y squared equal to 4ax. Here a is the distance from the vertex to the focus. That is already we are worked out, that is 2 units. Question itself they are giving y squared equal to 4 into the value of a is 2 here. Therefore we are getting y squared equal to 8x. Now I need to find the value of y1. Listen, this is the parabolic equation. It is passing through the point 3 comma y1. Therefore, this equation passing through, see the point P of 3 comma y1. 3 comma y1. A particular equation passing through this particular point, we are able to substitute here. This y is replaced by y1 squared. 8 into x is replaced by 3. Therefore, y1 equal to root of, here we can say 24. That can be simplified as y1 equal to 24 can be again simplified as, we can get in 2 root 2 again 3. Again it can be like this, keep like this also. No need, because we are working out y1. After that we are able to simplify. See, y1 equal to root of 24. We need width, here width equal to 2 times y1, that means 2 times root of 24. Or you can split 24 in the form of, as per as the simplification model you are able to work out. Take the units, 2 root 2 meters. So this is the y1 we are worked out. Here twice, we need 2 times. So this is the width equal to 2 times y1. So 2 times root of 24. Once again listen, we need the equation of the parabola. That is, the equation of the parabola is y squared equal to 4ax. That is, the y squared equal to 4ax. Substitute the value of a here. A equal to 2. That means 4 into 2, y squared equal to 8x. This equation passing through the point 3 comma y1. So substitute here, y1 squared equal to 8 into 3. So that means multiply with 8 into 3, we can get 24. y1 equal to square root of 24. This square root of 24 may be simplified. If you want, you can simplify. That means y1 equal to root of 6 into 4. We can get y1 equal to 2 root 6. If you know, you can simplify. Then 2 times we need 2y1. So root of, again, instead of this, you can replace this number also. This is the value of the, that means width of this antenna. In the same model, we are having some more parabolic equation. Keep the idea first, then substitute the data, then convert into the real parabolas. Which type belongs to? After that, substitute. You can try yourself. Now listen students, once again, we are having one more real life problem based on the parabolic. The equation y equal to, see here, y equal to, the given equation y equal to 1 by 32x squared. That means we can write this equation like this. X squared equal to 32y. So x squared equal to 32y. It is type number 4 parabola. Straight away we are able to, type number 3. Type 3. Open upward. So see, models cross section of a parabolic mirrors that used for solar energy. You are able to see the solar energy heaters. There is a heating tube. See the word, there is a heating tube located at the focus. This is the important word. Located at the focus of each parabola. Now I am going to select a parabola. See here. Why I am selecting this type of parabola? Straight away, type number 3, open upward. So in this type of solar heaters, see, many rays like this coming from the sun. The rays are coming from the sun, sunlight. All these rays are reflecting from this mirror and located at the same place. So this is now said to be a focus. So after reflecting by using this parabolic mirror, all these reflecting rays are placed at the focus. Here, see, placed at the focus, the heating tube. Here, the heating tube must be placed. Heating tube located at the focus. This is the concept. Each of the parabola. How high is the tube is located above the vertex? From this vertex, how high? We have to find from this vertex to this value. That means we have to find the focus value A. Vertex V, F is the focus. We have to find that VF value is already, theoretically we explained, value A. We need to find A. That is the question asked. Now listen students, this is the solar heater based on this concept only. The rays are coming from the sunlight and it is reflected by using this parabolic mirror. See, all the rays coming from the sunlight, all the rays are reflected at the same point. This point must be the focus. That is the logic. So see the question asked, how high is the tube located? So from this vertex, this is the height we are going to find. This is the height, now we are going to find out. See this parabola, this is type number 3. So we can straight away select a parabola in type number 3. So select the type number 3 parabola, straight away select it. So from this vertex we will know 0, 0. Here is x-axis. Focus must be 0, A. It lies on y-axis. Focus must be here 0, A. Now we have to find this value A. This is the height. We need to this height. Now it is finding the value of E. Very simply we are able to calculate this one. See the type of the parabola. X squared equal to 32y. It is nothing but x squared equal to 4ay. Already we say type number 3. So 4a equal to 32 here. 4a equal to 32. A equal to 8. Therefore, this is the value of A. From this value we are able to say, see how high. That means the tube located above the vertex at a distance of 8 units. That is your conclusion. The tube is located at 8 units from the vertex. So that's all. So we need A. We are able to calculate with the help of comparing the given parabola with the type number 3. So we can calculate A equal to 8. Therefore, here must be the heating tube placed from the vertex. Therefore, we are able to calculate the tube is located at 8 units from the vertex. So dear students, read the question carefully. So read the question. Then apply your practical knowledge. Here, we are able to apply the practical knowledge. These are all the questions based on real life problems. Real life problem means we are able to see all these type of solar heaters. You are able to see. So how the solar heater is working, you have to think. So this type of idea you are able to create. Then see this type of problem based on type number 3. Type number 3 parabola. Compare with this one. Then focus must be here. That is the question. In that focus only heater is placed. So that we need A. That is the calculation. Tube is located at 8 units from the vertex. So dear students, try yourself. So think your question, what they are asking. Put your knowledge. Try yourself. Whether you can get right or wrong, no problem. Try yourself and work it. Thank you.